It's a great pleasure to be here with all of you. And yes, maybe a brief introduction about myself. So my name is Alexandro, and I'm here together with my team. And I wish we had this program back in the days when I was pursuing my own research. And this is also the reason actually we ended up setting up this platform. So for the context, I had the privilege to do research on a campus where the biggest supercomputer in Europe is located in Switzerland, Lugano. But getting compute time there or access as a PhD to get compute time there was literally tantamount to writing an own PhD thesis. They gave you a long list of requirements that you had to provide up front, and there was no way for me to fulfill it. So the only option available was literally to go and build something that could help me conclude my research project. And as you will see later on, this was something that was designed by researchers for researchers. So our audience for this platform are subject matter experts. Probably the best users will be people like you, research software engineers who master all these best practices in computer science and have deep understanding also, or thorough understanding in the subject where they are working on. But collaborating and ensuring computational reproducibility is it's something that many of us still struggle to cope with it, because there are so many applications, so many new things coming around the corner, just trying to keep up with what's being published. It's literally a full-time job. So what I want to show you here today is Nuvolos. The name itself, it's difficult to remember, but I give you a hint. Coming from the Italian-speaking part of Switzerland, nuvola is the cloud, so it's the definition of a cloud. And olos is from the Old Greek knowledge. So this is the cloud where the knowledge gets created. So maybe you will remember that going forward. So I don't have slides. Why? Because I literally took the plunge to show you live everything. So this is my browser right now. It's my computer. I see I've shared everything, so I hope I won't get any messages in the meantime. When you sign in as a user, this is the dashboard that you see. Here you'll see three applications that my user is either running or used to run in recently. And in the lower part of this dashboard are the three types of projects that you are able to carry on or do in Nuvolos. Let's start with the middle column. You see there are recent projects. These are research projects. So think of it, it's like a workbench where you can do all this work that is required in a computational research projects, preferably or optionally, you can have also some degree or a lot of data, and the data and the applications that you are going to use in order to answer the research questions you are pursuing, we are completely agnostic to it. So data could be structured, semi-structured, or unstructured. Same is true for applications. You can use Python, which is currently very popular, but you can use any other type of application. It could be open source or it can be proprietary. For the proprietary applications, you can bring on your own license. You see here, in my case, I also have a MATLAB application running. I'm happy enough that my daughter is studying, so I was able to get her license to do the demo today. And on the left-hand side, you see what we call courses. What are courses? Well, when I was doing research as a PhD back in the day, the deal was, okay, you need to do also teaching. So you need to teach computational subjects or topics to students that were not at all interested in what you were teaching, and you spent most of the time actually trying to help them set up just this goddamn R environment on their device and have this famous hello world. So I always consider this as the dark side of being in the academia. You have to teach and you have to make them understand and acquire this digital skill. So, and due to the fact that the same actors who are doing computational research or doing the research are also required to do the teaching, we made sure that they have, back in the day, there were these rooms where they were full with the same hardware, the same software, the same operating system. and the lecturer was able to ensure that everybody had the same environment. So this is a lab as a service, the second pillar. And the third pillar, there are no projects these days where you don't have data. And here you can organize also all your data and subject it to version control, and then use subsets of every data set in a research project or in a class. It means that this is just a platform to go about the work, but to host data, but you need to have the data, or you need to acquire the data from wherever you want. Now, let's take a project as a use case. It's Project Inara. This is a macroeconomic model. I have a background in economics, so I didn't want to come up with something more like of the audience here. I didn't feel very comfortable with it, but it's a project that initially started development in MATLAB, followed by some libraries done in Octave, and then they adopted Julia as a more faster language. And now ultimately they ended up stitching together everything with Python. So we have 3 different languages. Now, just people interested to test the entire model, you know, they have quite a hard time deploying these 3 different environments just to be able to see whether this model is something worthwhile pursuing it. And you will be surprised, this model is actually responsible at central banks across the world for determining, you know, recommendations for their policies. So one wouldn't expect, and yes, it's typical, one maintainer, and this maintainer eventually got too old, ill, and now it's handed over to us in a safe harbor. And we wanted to make sure that whoever wants to play around with this model, it's very simple to do it. And this is actually the use case I want to present to you today. So what you see here now, it's a research project. And at the top, it's a multi-tenant service. It's fully cloud-based. It's built on top of Microsoft Azure. So for the full disclosure, this is where we get the compute and storage resources in order to be able to power these things. Everything runs in the browser. And just to give you an idea, at the top you have the navigation here. It's a tenant which is called demonstration. We are in the project dynamic. In the Nuvolos lingo, this is a space, and each space can have something which is called an instance. Well, you see here a master instance and another one called dashboard. Master, well, we are big fans of standards and of Git. So back in the day when the main repository was still called master repository, this is how we adopted also this name. Whenever you start a new space, you start with the master instance. And what is an instance? An instance is similar to a multi-user computer. It's a file system on which you can deploy any number of applications in containers, and to which you can invite any other number of users to collaborate with you. And each instance has a state. You have the current state, which allows you to run applications, to do changes, to add data, to delete data, to go about your work. And then we have the immutable states, which are point-in-time snapshots of this entire instance. Well, this is actually something of a killer feature. Why? Because this way we ensure computational reproducibility of all your work at that point in time. So I have here some of them. Coming back to the idea that everything is documented as in a Git, so you can start from a Git repository. What you see here is nothing else than the markdown file of a project. Then you have a file system that you can use in this very instance. You have the possibility to even store tables. So these are SQL compliant tables for structured data. And then are the applications. What are applications? Applications are nothing else than containers. So all the applications that you run in Nuvolos are in containers. Adding a new application, my user has now access to a lot of images that are enabled for my user, which my organization already cleared and whitelisted, and I'm allowed to use them. So if you want to deploy any kind of environment, it's as easy as on a smartphone. You can use, I assume that these days, most of you are very fond of this editor, and then you have a lot of versions there that you can deploy by simply choosing one that fits your requirements. And installing one, it's just like on a smartphone. It's a click, that was it. You have it, it's available to run. On top of it, you can also configure the kind of configuration of resources that are available to power it the next time you start it. You can choose from standard compute units, which are nothing else than one CPU and 4 gig of memory, any kind of multiple of it between 1 and 16, or you can even use, credits, which are a prepaid unit of accounting, and then plug in a GPU to train or to use it for whatever reason you want. And here, again, as simple, you just set it and it's there. Next time you start it, the user has everything in there. They don't have to worry about drivers. They don't have to worry about the integration with the file system, with the tables and those things. It just runs. And now you ask yourself, well, yes, that's not a big deal, but every application is running in the browser, even if I sign out until it reaches a specific timeout when automatically it will be closed by Nuvolos. This is MATLAB. MATLAB, some of you probably haven't heard a lot, but back in the day, this was very popular still in the academic and scientific world. The equivalent for MATLAB, it's Octave. This was never intended to be deployed and run in a browser, but as you can see here, it's still running, and it's the user experience is what was always at the center of the development of Nuvolos. So it's the human in the loop that we focus on when developing, when working with Nuvolos. So these are two applications that are running. Of course, you can also run this model that I just prepared. So it will start computing. The same is true here. If you want to do it in MATLAB, you just call this function. Oh, I need my glasses actually. And then they will start computing. The reason I'm showing you this is you will see then how the resources get utilized. So it's the same experience like on your own computer. It shouldn't be something new or proprietary. Everything is back in the familiar environment. And this is not all. So you can use applications in containers. It's the simplest way to get started. But each application is also allowing you to install additional packages using package managers like Conda and persistent. So they will be persistent, meaning that once you install it, so let me install now here in this VS Code maybe a new package, and all these applications you can make them available from one instance into another. So it means if you want to onboard a new team member or you want to share your work with the scientists of your team, all you need to do is just distribute the application from one instance into the other, and they are good to go. Or if you really trust them, you can invite them to work with you in the same instance. So it's really intended for collaboration and for computational reproducibility of everything you do. And of course, most scientists or most academic institutions, they have high performance computing facilities to which most of you or the scientists have access. For those, it's very simple to submit this image for computation to a Slurm queue. So until this application will start, let me show you how I prepared this. So think of the project Dynare, like the project or the space where we developed this very complex model with 3 different programming languages. And then I have another project where I deployed it. It's called Julia Dynare Computational Example, where I made it available to whoever is interested to test it and who has access to HPC. Well, when having access to HPC, what I need to do is I need to export my application. So you can just go here, very simple, and say export application. I did this for you already. I wanted to have the available. And now, as you can see, I have here the possibility to copy a snippet in order to be able to submit this image to HPC for compute, and then get back the results into Nuvolos, create a snapshot, and ensure that. You can even run it locally. So if you want, you can run locally this image if you have a performant computer, and nothing prevents you from that. So I started here my application. It's another Visual Studio Code. Here, all I need to do is open a new terminal. As you can see, it's just a terminal. You can see. Oh yeah, and log in to the node, and then just submit let's see, do we have still something running? No. So all I need to do is then submit my job to, so it's in, I created an SPatch queue, SPatch file, nothing extraordinary. So again, same procedure like you are always used to do, absolutely tractable, and submit the computation. And yes, then you should see the job running like you're used to do it. There is one caveat, of course, it will run with resources of one node because I haven't created this solution to use message passing interface to be distributed across several nodes. But most jobs, in our experience, can run on one node in that respect. So you are not constrained to use the computational resources of the platform. You can use whatever computational resources you want. You have the possibility to get started in minutes or even seconds. You don't have to spend time on ensuring that your programming environment and everything else can be are consistent, because the images that have been provided there to you are already production grade deployments and Docker images. And once this computation is finished, you can bring them back and put them into a snapshot. So to conclude this, having a project where you are working together with others and you want to ensure a simple way to share environments, to create these environments as containers, and then have them being computed wherever you want, this is the fastest way to get started. So this is a research project. In the meantime, hopefully also my, oh. So you're started an A10. Oh, great. So I started this application with an A10. Now you see how long it takes for Azure to actually make this available to us. It will take probably by the end of the presentation, we will get the A10. So it's not our fault. It's Azure who takes a lot of time to make this GPU available to us. In the meantime, what I will do here, I will show you the other aspect, which is, okay, so I created this model, but I would like to use this model to teach or to subject it to peer review. What I'm going to do then, I'm going to have a class. I have here an example, which is called Selected Mathematical Topics for Data Science. And here, this view is the instructor view. Again, it's the master instance. And here you see, again, you have the description of the class, it's markdown, everything. You can even integrate videos into your markdown here that you can store in a video library. Again, just to be consumed within Nuvolos if you don't want to have them publicly available. And can create assignments, and everything here is distributed by the instructor to the participants. So you don't have to expect that the participants have a skill level that know, for example, on how to use Git in order to get the latest teaching material or the code or the data that you want to teach in that class. You just distribute it from your own instance to their instance. And here you will see the Zoom bar. Okay. Well, I don't know how to put it in. Okay, you can also go into the students' instances and see exactly what their status is, whether they handed in their homework or not. And again, you can see what's happening on their file system, what tables they have, and what applications they have there. When they submit their assignments, as an instructor, you would want to actually have these assignments run in the application of the student's instance. So yes, this is also supported. It's also supported to create group assignments. So if you want to have 2 or more students work on an assignment, you have what is called a group instance. And this will enable you to actually focus on the curriculum instead of focusing on making sure that everybody have their instance up and running and is able to follow the syllabus. So this is in a nutshell what Nuvolos is all about. And yes, of course, you have also here the possibility to create data sets, also versions of the same data set. We call them in Nuvolos vintages. And it was designed, again, by researchers, for researchers. And we never assume that our users are DevOps, infrastructure engineers, or particularly keen to learn things that are not their core competence. For them, the most important thing is they want to get answers to the questions that they are researching. So if you're interested to test it, I will be very happy to give you the possibility to do it. And we've done it this way. So it's here. You have a QR code that you can sign into it, and everybody can have access to it. So for this conference, they have a free access over a period of a couple of weeks. You can invite anybody you want to this platform. By the way, we support single sign-on with your institutional credentials. So it means that we are part of the EduGain network, which allows you literally to sign in then with your own credentials from your institution. Of course, we support also Google. This is the preferred way, especially for researchers and students when they sign in here into Nuvolos. But it's something that gives you actually the possibility to prototype super fast, to share your work and ensure computational reproducibility of whatever you do in your team.
Yes, we're a little ahead of time then, so we have a bit of extra time for questions. And I saw there were quite a few coming in on Slido.
Okay.
So let me get that up. There we go. They're on the screen as well.
Oh, great question. Yes. Can I run Nuvolos on the on-premise hardware? The answer is very soon. Yes, you can run it. So it's the requirement is a Kubernetes cluster, and right now we have a lot of interest from many institutions who would like to have this on premise. It's just that, again, you need to involve your IT department and get their buy-in to support this deployment. And in the backend, although we consider us just so very skillful plumbers, it's a lot of work to make it and keep it up and running, especially like in our case, we have currently over 11,000 users, over 65 academic institutions, also here in UK. So yeah, you need a team to be able to manage it. But yes, it will become available for on-premise deployment very soon.
Thank you. The next question we've got, it's just moved. How does taking a project snapshot allow for reproducibility? Are the changes taken between snapshots recorded in some way?
Yes. So when you take a snapshot, it's literally, if it's triggered by the user, it's a one click. So you say, take a snapshot, and absolutely it will make a snapshot of the entire instance. However, Nuvolos goes beyond that. If your application is stopped due to inactivity or because it stopped the computations, Nuvolos will take also automatically a snapshot. You can also document each snapshot and comment why you did that. Beyond that, when you want to test in Nuvolos, you can create at no cost an instance in a very fast time. And why? Because we want you to be able to test just a specific aspect of a problem in a new instance and just make sure whether it works or not, and only later on. It's similar like in Git. You branch out, test something, and then bring it back into your main repository. So you have a big, how you say, options on how you take the snapshots, how you document it. And yes, everything that is in this snapshot can be then restored either in the current state, or you can create a complete new instance out of it. And then you can compare everything, because effectively you have two complete copies of this instance.
Thank you. This next question is one that has given me pains in some of our cloud administration. Is the platform able to manage budgets and spending limits? Particularly, I guess, in research, we often have fixed budgets.
Yes.
Compatible with cloud often.
The short answer is yes, absolutely. And what I haven't showed you, I should have actually, you can't spend more than you have. So the pricing is very simple. You pay a license. Within this license, you get a set amount of compute hours for the compute units. And then you can also buy additional credits if you want to scale up, like me now trying to get this graphic processing units there. And there you need to have at least a balance that allows you to run for a half an hour in order for Nuvolos to allow you to scale it up. So you can never experience what most of us has experienced with infrastructure as a service provider. At the end of the month, you get the invoice and kind of, oh my God, how am I going to explain this? So yes, no, you have a lot, we call this resource pools, and you can create for every user a resource pool if you want, and you can definitely, even now in classes, you can define budgets for students where you say you need to solve this problem with this amount of compute resources at your disposal. So yes, you have very granular control.
Thank you. I think we've got time for a few more. Is there a free plan for students that we can demo out with MSCs and get them to come on?
Yes. So for students, we have actually two programs. We have a fellowship program. PhD students usually get a PhD grant or fellowship grant over the 1 year where they can do their work. And they get also credits and complimentary access over 1 year. For MSc students, usually we require that the institution actually commits themselves, because there is self-management, everything. So we are completely hands-off here, but there are a lot of ways on how this can be done. And yes, for carpentries, we learned this structure here in the UK. They will be very interested actually to collaborate. And after a class, students have a grace period of up to 6 months, I think, after which they still can access the course material. Of course, everything can be downloaded as an image and run locally, and everything shows up in the browser, but they still have access for 6 months then to direct access there. Actually, Imperial College was very nice. After the introduction to Python, several students persuaded the dean to keep on the subscription because they were still on using it like this. Yes.
Okay, we might have time for the next two then, if we're very quick.
Yeah.
Can I bring my own Docker images to the platform?
Absolutely, you should. It will then have to pass a pipeline of checks and balances, but yes, that's the idea. And hopefully soon we will have this fully automatized to the degree that, you know, you submit it, if it complies with specific requirements, then it's there. And that's exactly the idea. The organization or the tenant in Nuvolos can make available whatever images they want for their users, and all else that is provided by us, we are adamant in respecting whatever the developers of an environment or whatever they've done is there according to their specifications.
Excellent, thank you. And I think the last one, and this is related to a previous question you had, I think, about deploying on-prem. Can I deploy this into my own institutions as your subscription? Is that on the roadmap, or is that something that's possible at the moment?
Right now, it's not possible. So right now it runs on top of Microsoft Azure, because they were the only one who had the capacity of resources that we require. But yes, we are working on what we call right now the self-management version of it that can be deployed on any Kubernetes cluster. So which means it could be in AWS, it could be on-prem, it could be wherever you have a Kubernetes cluster.